Hello. So what I taught you yesterday is a little bit confusing, and I got some questions from some people that are generally pretty good at physics. So I'm going to do a couple more problems from this kind of style, where I give you a roller coaster type thing, I tell you how heavy an object is, where it starts, and I ask you for the kinetic energy or the speed at other points. Here we go. So let's say that we have this roller coaster ring. Point A is 50 meters above the ground, point B is 25 meters, point C is 30 meters, point D is 25 meters also. The question is, a 500 kilogram roller coaster starts at rest from point A. Find the kinetic energy at every single point. And what we have about these points are only their heights. So I'm going to need to figure out the kinetic energy at point A, B, C, D, and that's it. I know that at point A, it has no kinetic energy because it starts at rest, but for every single one of these, the way you're going to get the kinetic energy, unless it tells you that it's at rest, is going to be the same. You're going to write the total energy equation. So for every single one of these, the kinetic energy plus the potential energy is going to equal the total energy. And we're going to pretend like only gravitational potential energy exists right here. So for every single one of these, I wrote down the fact that the kinetic energy plus the potential energy equals the total energy. What's important about this is that what I wrote right here, Ke plus Pe equals Te, even though these all look the same, these are not four different copies of the same equation. And the reason why they're not is because point A, this is the kinetic energy at point A, and the potential energy at point A. This is the kinetic energy at point B, potential energy at point B. The kinetic energy at point C, the potential energy at point C, and then at D and D. The thing about this that is the same with all of them, though, is the total energy, right? The total energy is the same for every single one of these. This total energy number is the same in every single point because energy is conserved, which means that it does not change over time. But the kinetic and potential energies, these might change. So the kinetic energy at point A is not necessarily the same as the kinetic energy at point B. I'll tell you how to solve this. You use this formula, basically. We need to figure out this total energy once. So if we can figure out this total energy at one time, at one single point, and we have enough information to figure out at point A, so we'll do this. If we can get the total energy at one point, we know that that is the same for all of these other points because it's conserved. The potential energy we can figure out because it, in this case, depends only on the height, and we have the height of every point. So I'm going to show you how to solve this basically. Over here. Point A is 50 meters up in the air, and we know that the roller coaster starts at rest. So that tells us right here, at point A, that the kinetic energy is 0 because it starts at rest. And the potential energy is going to be mgh. So mgh, where mass is the mass of the roller coaster, which is 500. G is the acceleration of gravity, which is 10 meters per second squared. And the height of point A is 50 meters. So the potential energy at point A is 500 times 10 times 50, which is 250,000. So the total energy at point A is going to be 250,000. The reason why we did that, the reason why this problem had to give us all of the information about a single point, the kinetic energy information and the potential energy information, so the height, was because we need to figure out the total energy once. But if you know it once, we know it every time. So the total energy at every single other point is similarly going to be 250,000. Okay, so now we know the total energy. We figured it out from point A because the problem told us the kinetic energy and the height from which we could figure out the gravitational energy. So we figured out the total energy. That's the same everywhere. Now, if you look at this roller coaster right here, it says find the kinetic energy at every point, and notice that at every single point we have the height. That's important. We have the height at every single point. So if we have the height, then we know the h of the mgh, and we can figure out the potential energy for every single one of these. So let's figure out the potential energies at every point. And I give myself some extra space here because I'm going to need it when I plug in the numbers, but at every single point, the potential energy is m, the mass of the roller coaster, which is at every point the same. It's going to be 500 kilograms. And g is the acceleration of gravity, which is at every single point going to be equal to 10 meters per second squared. H is the only thing that's going to change. You can see that point A is at 50 meters. Point B is at 25 meters. Point C is at 30 meters, and point D is at 25 meters. So, okay, so now what I've done is at every single point where there used to be just PE for potential energy, I've actually put in the equation, which is the mass times the acceleration of gravity times the height of the point. And now I have everything I need to figure out the kinetic energies. This is now a bunch of algebra problems with only one variable. This is the variable. So let me actually multiply out these numbers. And then now notice that for every single point I have an algebra problem. I guess I really didn't need to do it for point A because I already knew that the kinetic energy was 0. But for every single other point now, I have that the kinetic energy at that point plus whatever the potential energy at that point happens to be is equal to the total energy, which is 250,000 joules. So now I have a lot of algebra problems, and all I have to do is take this number, subtract it from this number, because I have, kinetic energy plus that equals that. So I just have to subtract, that's algebra, and then I'll get the final answer. So let me do that real quick. Okay, and then this is your final answer. To figure out the kinetic energy at point B, you say the kinetic energy plus 125,000 equals 250,000. So you subtract, and you get that the kinetic energy at point B is 125,000. For point C, the kinetic energy at point C plus 150,000 is 250,000. So you subtract those, and you get that the kinetic energy at point C is 100,000. Then at point D, you get kinetic energy at point D plus 125,000 is equal to 250,000. So you subtract that from that, and what you get is 125,000. Point B and point D have the same amount of kinetic energy, and that makes sense because if you look at point B and point D, they're actually the same height. Point B is 25 meters above the ground, point D is 25 meters above the ground, so they should have the same gravitational and kinetic energy. And then I guess I should write it down to the kinetic energy at point A. This is not something I figured out, the problem told me this. The kinetic energy at point A was 0 because it started at rest. So that's the answer to this one. What you do is you figure out the total energy at one point. You can use that to figure out the kinetic and potential energy at any other point, right? But you need to be given one of them. So if you know the total energy and the gravitational energy, then you can get the kinetic energy. I know doing it with 4 at a time can maybe be a little bit overwhelming, so I'll just do one. A 10 kilogram object starts at rest from point A, right here, 40 meters above the ground, before rolling down to point B. What is the kinetic energy and speed at this point, point B? So what we need to do is we need to figure out the total energy and use that to get the answer. So I'll write down two different equations. At point A, we have that the kinetic energy plus the potential energy is equal to the total energy. That's true at point A. And at point B, we also have the kinetic energy plus the potential energy is equal to the total energy. Also true at point B. The kinetic energy that I'm talking about here is specifically A's kinetic energy and A's potential energy. Over on the right, it's B's kinetic energy and B's potential energy, but the total energy is actually the same for both of them. So the total energy right here is the same in both of these equations, and that's why this is helpful. Because the question asks us about the kinetic energy at point B, so it asks us about the kinetic energy at point B, but it gives us information only about point A. It tells us that it starts at rest, and so the kinetic energy at point A is 0. That's what this means. And what we have to do is we have to use this information from the problem. So the informational part is only about point A. We get the total energy at point A, and that tells us about point B, which is where our answer needs to be. So let me do it. I need to figure out the total energy at point A. So the kinetic energy at point A, well, it tells me it's from rest, right? So the kinetic energy is 0 at point A. So the kinetic energy at point A is 0. The potential energy at point A is going to be mgh, so plus mass times the acceleration of gravity times the height. We know that the mass of the object is, let's see, a 10 kilogram object starts at rest from point A. So this is 10 kilograms right there. The acceleration of gravity is also going to be 10 meters per second squared. And the height is going to be 40 meters. So the total energy at point A is 10 times 10 times 40, which is 4,000. Okay, so I figured out the total energy at point A of this roller coaster. The problem doesn't ask me about point A, it asks me about point B. So what I have to do is I have to take this information and carry it over to my point B equation. So now I have the kinetic energy at point B plus the potential energy at point B is the total energy, and the total energy is not at point A or point B, it's the same for the whole roller coaster. So now we'll just fill in the fact that I know. The total energy is 4,000. And I also can figure out the potential energy at point B, because I know the point B is 15 meters above the ground. So if it's 15 meters above the ground, then the potential energy at point B is going to be mgh. And the mass, just the same as before, is 10 kilograms. The acceleration of gravity is also 10 meters per second squared. But the height is not the same as it was at point A. If you look at this, at point A the height was 40, but at point B the height is 15. So that's what changed here. This is only 15 now. So we can figure out the potential energy by multiplying all these together. 10 times 10 times 15. And that's going to give you 1,500. So 10 times 10 times 15 is 1,500. There we go. And now this is our equation. And I know maybe all the colors are confusing, so let me just write it out. What we have is that the kinetic energy at point B, which is what we're looking for, plus 1,500 is equal to 4,000. And this is now a pretty simple problem. All you have to do is you have to say 4,000 minus 1,500 to figure out the kinetic energy. And you can figure out that the kinetic energy at point B is going to be 2,500. So that's half of the problem done. Let's see. It says, what is the kinetic energy and speed at that point? So I figured out the kinetic energy at that point. It's 2,500. I can figure out the speed also, because you know kinetic energy, right, isn't really a thing. Kinetic energy is kind of like a shortcut that we use because we don't really like to write this down all the time. But 1/2 mv squared. That's what the kinetic energy really is. So what this equation up here, it says that 1/2 mv squared equals 2,500. And so we can figure out the mass. Well, we don't have to figure it out. The problem tells us that the mass is 10. A 10 kilogram object starts at rest. So the mass is 10. The v actually stands for speed, not velocity. I know it's a little bit confusing. So this equation turns into 1/2 times 10 kilograms times v squared equals 2,500. And you do some algebra on this, and you can get that the speed of the object is 22.36 meters per second. So I hope you understand the basic process of solving these problems. Basically, you can have any sort of path and a lot of points on that path. Every single individual point gets an equation. So for example, at point A, you have that the kinetic energy at point A plus the potential energy at point A is equal to the total energy at point A. And then also for every other point, so for example, like point E, I don't know why not, the kinetic energy at point E plus the potential energy at point E is equal to the total energy at point E. The problems that we ask you will always give you all the information for one point. So we will give you the kinetic energy at point A and the potential energy at point A. We will ask you something about the kinetic energy at point E, and we'll give you something about the potential energy at point E. Normally we give you the height. So maybe the height is 10. That lets you figure out the potential energy. The way you solve these problems is you always use the situation that you know entirely. So I'll tell you that it starts at rest and that it's, 20 meters above the ground, right? You use that to figure out the total energy at one point. The key here is to realize that even though the kinetic energy at point E and the potential energy at point E, this doesn't equal this, right? That's not the same. These two are not the same. What is the same is the total energy. So there is a connection between them. So you use the total energy from the situation that it fully describes for you. You plug that number in there. Then normally you figure out the potential energy from the height that it tells you, and use that to figure out the new kinetic energy. So you kind of have to do this equation twice, one for a point that you know entirely, and then one for a point that you don't know everything about. The total energy connects the two. I hope that was helpful.